All right, so we're going to work on 5-5, which we're going to do a little bit more with asymptotes today. Okay, so in the end, we're going to graph, but on the way, we have to do some other things. So it says graph r of x equals x plus 1 over x plus 4. So on the way, we have some steps to do. Step 1, we're going to factor the numerator and denominator. Okay, it's already done on this problem. Step 2, write r in lowest terms. Again, that's already done. Step 3, we're going to locate the intercepts. Okay, this is brand new, this section. Okay, but nothing impossible. So the first thing we're going to do is find the x-intercept. Okay, the x-intercept is going to be found by taking the top and setting it equal to 0. So we could go the long way about it, but there's really no reason to. And I alluded to this earlier in the semester that this was going to happen, that we were going to deal with the top part. So the x-intercept, we're going to deal with the blue. Okay, that's what's going to happen here. So x equals -1, so we get the coordinate -1, 0. The y-intercept is found by making x equal 0. All right, so y equals 0 plus 1 over 0. Sorry about that. No. Whiteboard disappeared. Oh, all right. Okay, so we were doing 0. Oh, there it is. Oh, great. Let me fix this up here. That's going to bother me. There it went. Okay, 0 plus 1 times 0 plus 4. Well, look what happens there. I get 0 on them. We can't have that, so there's no y-intercept, which likely means that there's an asymptote. Step 4, locate vertical asymptotes. Back to the last section. Okay, again, we're going to take the bottom, set it equal to 0. Okay, so x equals 0, x plus 4 equals 0. So our vertical asymptotes are x equals 0 and -4. Step 5, we're going to go to a new page. Locate the horizontal or oblique asymptote. Okay, if you look at what happened on the other page, we can't really do long division very easily here, so I'm going to multiply it back out. X plus 1 equals x squared plus 4x. So now I'm going to do long division with that one. So we have x squared plus 4x, over x plus 1. And here's where you're supposed to realize that x over x squared simplifies to 1 over x. So we get 0. So y equals 0, which makes sense when we had no y-intercept. So remember, I'm gonna write it in a different color. We had no y-intercept. So that makes sense because we have an asymptote there. All right. Step 6 says to graph using calculator. So that's pretty easy. Just type it in from your original graph. And then step 7, you're going to graph by hand. Okay. So we're going to use the pieces of information that we know. Okay. We know that we have a intercept at -1, 0. We know that we have a vertical asymptote at 0. We know that we have a vertical asymptote at -4. And we have a horizontal asymptote at 0. Okay, and then when you look at your graph on the calculator, it's a little bit easier to see what's going on. We have this graph that looks like that 1/x graph, and the same thing over here. Gets really close, really close, really close. And then we have this graph here. And it goes through that -1, 0. So it helps guide us. We know where the asymptotes are exactly. We know what point it goes through because we calculated it all. And I believe my math lab might make us do all that. Okay, we're going to do another one. H of x equals x cubed minus 1 over x squared minus 9. Okay, so step 1, let's go back to the first whiteboard. Says factor the numerator and denominator, and then we're going to write it in lowest terms. All right. Step 1, step 2. We're going to do it at the same time. Okay, so we're going to get x minus 1, x squared plus x plus 1 on the top. Difference of cubes. The bottom is the difference of squares, x minus 3, x plus 3. Nothing cancels out, so we're good. All right. Step 3 says to find the intercepts. Okay, so remember, we're going to take the top and set it equal to 0. Okay, here's one thing my students do is they think that right here, that trinomial will give us another intercept, but it won't. Only the binomial. So x minus 1 equals 0. So we get the intercept 1, 0. Okay, when you look at the y-intercept, go back and look at the original. Realize that when we put zeros in there, we get 0 minus 1 over 0 minus 9. So we get 1/9. So we get 0, 1/9. Okay, step 4 is the vertical asymptotes. So take the bottom and set it equal to 0. So we get x equals plus minus 3. And step 5, we're going to do long division. X squared hold on. Undo. There it goes. I was like, what happened? All right. X squared minus 9 into, don't forget to put your placeholders in, x cubed plus 0, x squared plus 0, x minus 1. Okay, so we get x on the top, we get x cubed minus 9x. Go ahead and put a placeholder in if you need it. Okay, when I subtract, remember that I'm going to change signs, plus, minus, plus. So I get a positive 9x minus 1, but then 9x over x squared is not going to come out nicely, so don't worry about that. We just get x. So my answer here is y equals x. So this one is an oblique. All right, so now we're going to go and graph it. Okay, make sure you check your calculator. But again, I'm going to use what I have. Okay, I know that the x-intercept is at 1, 0. And I know that the y-intercept is at 0, 1, 9. So barely across the y-intercept. All right, so let me draw my asymptotes. My vertical asymptote is at 3. And negative 3. All right, now my oblique asymptote is at y equals x. So we start at 0, we go up 1 over 1, up 1 over 1. So it's the one that divides it directly in half. And then look at your calculator. Okay, you make sure you zoom far enough out to see that it hugs these lines. Let me kind of fix this one a little bit. Didn't quite draw it correctly. Hugs these lines. Same thing down here. It's going to hug those lines. And then here in the middle, it kind of does its own thing. So it's going to cross that oblique asymptote. So I'm going to kind of draw this part first. And again, it hugs the lines. So it's very unique in itself. All right, so the last one we're going to do is a good one for us to look at. It doesn't pop on a test, but I really like this problem. So it's going to ask us to find a rational function that might have the given graph. So we're going to work this out. I'm going to draw it out for you. One, two, three. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. I'm going to draw the asymptotes in. These colors are super helpful. I think they're helping a lot more than I realized. And then there's one down here. And let me draw the graph. Oops. Let me kind of draw this a little further. Because these hug down here. This one hugs down here. And then we have this. Let me draw it a little better. I did not want that to happen. That's, I guess, oh, no. Let's undo. Forgot about undo. All right. There we go. Okay. Nope. That was not what I wanted. There we go. Okay. I wanted it to, I guess if it's like this, probably is more like this. But never mind. Let's undo that. Because of how they've all been like this. All right. So they're going to give you multiple choice. So I'm not going to write r of x. It's going to take up too much room. We get 4x squared over x squared minus 9. We get negative 4x squared over x squared plus 9. We get 4x squared over x squared plus 9. And we get negative 4x squared over x squared minus 9. Okay, so a couple things off the bat. We have an x, y intercept at 0, 0. Okay. And we have vertical asymptotes at plus minus 3 and a horizontal asymptote at y equals negative 4. All right, so the first thing I see right away is these vertical asymptotes at x equals plus minus 3. That's going to give us x plus 3, x minus 3 on the bottom, which simplifies to x squared minus 9. So I can, because of that statement, cross off C and B. Now I just need to determine what happens with that negative. I have a negative or a positive, okay? So from that, I just need to determine, well, that's gonna do a parabola. So I either have a negative parabola or a positive parabola. That's what's graphing, okay? That's where that's coming from. So it's a regular parabola. So it's going, you would think it would be A. Okay. So I would just do at this point, I would check. The only other thing I have written down is that it has an even multiplicity. Okay. But apparently I have the answer is D. So I'm going to double check on my calculator to triple check for you rather than give you the wrong answer. 4x squared divided by x squared minus 9. Yeah, okay. So what happens when we get the positive 4x squareds? The positive 4x squareds is affecting these pieces. So it's dealing with these pieces down here. So it's really going to affect the asymptotes that are in the corners. So we want this one because it's going to flip everything. Okay. So again, it's a good one to think through. Obviously you get 3 chances, so we can easily narrow it down to 2 and you can pick one. So I just wanted everyone to work through this problem. So there aren't a lot on this assignment, so that'll be easy for you guys next week.